So I'm Steve Van Lare. I'm the head of the cognitive team here at Automation Anywhere, and I'm the second half of the Steve Squared joke, so I get to carry it on. We were disappointed that Brendan wasn't named Steve as well. I mean, we put it in the job requirements when he interviewed, but it just didn't work out. But we tried. So I'm going to talk about AI today, and I'm going to talk about what AI is here at Automation Anywhere. Obviously, AI is a huge topic, and I could ramble on about this for a very long time. The other direction I could go with it is talk about IQBot. IQBot is our flagship cognitive product that we have here at Automation Anywhere that is going to take documents and turn it into processing. But just like when you talk about software, it's a lot bigger than just Python. When you talk about AI, I have to admit it's a lot bigger than just IQBot. So I'm going to start with breaking this down into what the components are and how we think about AI, how it interacts with RPA and builds upon the capabilities that RPA has, and then where we're going with it and what we're doing with AI. So I think the first part from a definitional point of view is how do we define an AI solution? How do we define a cognitive capability? And ultimately that starts with software that learns, software that gets smarter over time. So you didn't just write it, you perhaps trained it from a data set, you perhaps have it continue to evolve after it was initially created and move forward. So that's one of the big hallmarks of any sort of adaptive system. For us, one of the really important things also is that it's open. So RPA, by its very nature, is an open system. Steve talked an awful lot about how we can connect pretty much to anything. And that continues into the AI space. That continues in what we are doing today. So whether you're using Google AI, whether you're using Microsoft cognitive tools, whether you're using anything else that you might want to grab, you can interface to it through RPA, pretty much through the same set of tools that RPA exposes. You can call the REST endpoints, you can integrate scripts into your bots, you can, even if need be, go to the glass and pull things off screens and get access to anything that you need. So we will integrate with any of the tools that are out there. And we have great examples of solutions with our customers that have done exactly that and put things together. But I want to organize this a bit more than that ultimately, because from a developer point of view, the suppliers that create bots, the suppliers that create solutions for our customers, they're interested in what components can I access? How can I build a bot? Where do I put my ML? How do I save it? And all of the components we build ultimately help broker how you build those connections into AI tools. But the business user, the people that are actually using RPA, are interested in what problem am I going to go solve? So coming back to IQBot, I'm going to take a piece of paper and I'm going to translate that piece of paper essentially into a spreadsheet. So you can then take that spreadsheet and go anywhere you want with it in your RPA solution. So if I'm going to take billing material or shipping material, and in that shipping material there's a tax implication, I can process all the paper that comes in the front door, I can extract out the tax information, and I can build a bot that can stuff that into my SAP system or my Oracle system and have a complete end-to-end skill. That's what's interesting to the business user. So ultimately we want to break the flow down and think of it in terms of what pieces are we consuming, how do we enable the developers to assemble those tools and make them reusable? And how do we deliver value then to the customer as a set of skills for what we do? So this is how we think about AI from an overall kind of big picture point of view. I'm going to break this down now and go into individual steps. And certainly feel free to ask me any questions anywhere along the line. We define an AI component to be anything that's part of the solution. So if I want to get access to TensorFlow and I want to build an image recognition capability, your typical business user is not going to integrate to TensorFlow. They're not going to open up a box and they're not going to say, hey, let's pull in a neural network and let's start training it to do something. But a developer is going to want to be able to connect to these various systems. And so whether it's just the raw ML skill sets, whether it's the raw components that are going to extract information or do some work, or even if it's pre-trained elements, these can all be exposed as actions inside of RPA. So when Steve talked about actions and bot runners and where everything sat, most of these things will get picked up and they'll get exposed as an action that somebody can consume in a bot and put it there. Stanford NLP is a good example. If you want to do some intents, you can take some documents, you can train them up, and you can call that intent, and it's right there to put as an action in a package inside of RPA and plug it in. So whether it's vision, whether it's language like I just described with Stanford, whether you want to take that up and use some of Microsoft's tools and generate voice or Amazon's tools and do that, or whether you want to connect in and do something deeper with inferences, these are all components. And so you can think of these as the building blocks. So if you want to build a skill, what building blocks do you need to put that skill together as a developer? And this is where you start. You look at the actions and you put them together. Skills end up being the things the business users want to talk to you about. So I talked about IQBot, the ability to take a document and turn that document into something that I can consume in RPA and infer the information that's on that document and use it. I can do the same with building an application and a skill that can translate emails into intent. So if I want to front end my Workday system and I want emails to come into the HR inbox and extract out the intents as a skill, this is the place to build it. So anywhere you want to build something where the business user can take a set of sample documents, put them together, and train up what you're doing without having to have a data scientist, without having to have a developer involved, you graduate to building skills at that point in time. And when Brenda gets up and we talk about the bot store, we'll talk about how you can deploy these skills and you can make them reusable across the larger community. When I said adaptive is a hallmark of any sort of learning system, these are the steps that are involved. The first thing you need to do is you need to build your AI. You need to build the components together to create the solution that you want to put together. And RPA is uniquely valuable in doing this in terms of pulling the components together in the form of a skill or a bot and making them work. The next step is to train it. And sometimes people get hung up about the difference between learning and training. We separate them because we think of them in terms of bulk training. So if I've got 10,000 sample invoices that I want to train and have the system go through and build its own models based on those documents, that's the training step. And there's a little bit of human supervision that you can either bring or you can let it be unsupervised, but that bulk training is the first step of the process. Once you've trained it, you then have a model, and that model has to run somewhere. You have to put the model someplace, you've got to deploy it so that you can execute it, and new documents can come in, and you can make decisions on those new documents that are coming in. And so the learning step, which is an awful lot like the training step, but it's different by virtue of the fact that it's typically a single document at a time. It's a single event that's coming through, and that's your feedback loop. That's where you're going to take the inbound stream of information, and from that inbound stream, you're going to adapt the model and continue to make the product smarter and smarter. In IQBot, we measure STP. STP is straight through processing. How long does it, or how many documents go from the input of the system to the processing, wherever you want to put it, if I'm going to put it in my Oracle system, how many go straight through without a human touching it? And I want to distinguish between an augmentation and an automation use case. An augmentation use case is one where the machine is helping the human do more of something. So if I was processing 10 documents by myself, I can now process 100 documents if I've got an augmentation solution. If I'm using an automation solution, the human goes away and they do another job. And the machine takes over and processes documents, and you only deal with the exceptions at that point in time. So IQBot's an automation solution, and we measure the straight-through processing. So out of the box, when you complete the training, you've got an initial straight-through processing number. And then as you get smarter with more documents that come up, your straight-through processing number increases over time, and the system gets smarter and it adapts to what it's seeing coming into it. So those are the categories we break them into. Let me jump down into each one and talk about them a little bit more in the context of RPA. Where do some of these things reside and how do they work together? So we will leverage any AI stack. We'll leverage our AI stack, we'll leverage a third-party AI stack, and it's one of the beauties of the openness of RPA is that we can grab onto these different things and consume them. If you take one of the tools and you create it into a bot, we can put that in the bot store, and then obviously download that into the bot runner at some future point and run it. When I get to the deploy step, I'll talk about all the different places you can put things, because AI has some interesting asymmetry problems where the training is usually far more expensive than the execution. And one of the joys of RPA is it's really a big data platform. We don't talk about it that way, but you put the bot runner anywhere you need to execute code. So if you need to execute code on a GPU box, you put the bot runner there and you do your training there. If you need to be executing close to the user because you need access to a particular UI or a particular tool, you put the bot runner there, and the control room orchestrates where all this goes. So when you build these components, you get to be wonderfully ignorant of most of this, and you assemble the components you want into a bot, and then you can install that inside the bot runner to consume later. The training, this is where things get expensive. And this is where things get a good bit more interesting. A lot of times, the training obviously is going to happen on the customer's data sets in their facilities, whether the data is in their databases, whether it's on file servers, wherever it happens to be, the bot runner goes in the appropriate place. And a big part of our job then is to take the components and the parts of the skills that we've developed and make sure that they're sitting close to the data so that you can do the training in that spot, produce the models, and then make the models available for the execution phase when you put that together. So again, we don't really care what AI solutions we end up integrating to in this market because we leverage the components that already exist to make these skills really valuable for our customers and to really help out simplifying the deployment and the execution of these things. The example I want to use, I'm going to start with IQBot, and then I'm going to go to a third-party example so you can see what the differences are from our perspective. If I take the invoice case I started with before, and I use IQBot, I'm eventually going to produce a model. That model we call a learning instance, and that learning instance can be either taken intact and shared somewhere else, or that learning instance can be used locally. So we want to make for the developers it easy to create either the raw components or the complete skills that actually do something out of the box. The NLP example I used would flow through in this same mode. You would do some trainings, create the intent, and then that model from that intent could be pushed up to the bot store and then moved down to any server that you wanted to put together. We did a use case that was mortgage applications. Fairly straightforward solution. You've got a large array of data. What mortgages have you approved? What mortgages have you not approved? And used a tool to essentially analyze that, build a model. That model works the same way. The learning instance can be packaged up and put in the bot store for others to use, or you can just load it locally into the bot runner and update it as you go forward in what you do. So one of my favorite things about the two slides is they're identical, whether it's our AI solutions or whether it's a third-party solution. Our goal in terms of the openness is to make sure that we're enabling for others the exact same things that we're doing with the solution. Because AI, it's a lot bigger than just all the tech that you can get from IQBot and all the tech you can get from Automation Anywhere. It's not really going to touch Mihir's vision of changing how work is done and changing the way bots are deployed unless an awful lot of other developers and other people work in this process to help deliver value.
So you mean basically that if in the past someone has been overcautious with mortgage applications, then people stop getting mortgages?
So ultimately, the use case that was put together was for a particular bank and a particular problem. And they were trying to automate the approval process. And there's ones where, from a confidence point of view, you can say very easily that, yes, this one is appropriate to automate, let it go by. When it goes through the process, if your confidence score is, this one's kind of iffy, why don't I have a human get involved in it and regulate it? So it's not so much about trying to take away the human's ability to help make a decision for somebody's mortgage, but it's allowing the human to spend more time on the ones that are important as opposed to the ones that are easy. We did the tax example I used earlier. It was a business that had a large team of people that were literally taking pieces of paper, highlighting the word tax, moving it to somebody else to create a spreadsheet, who was then loading it into their ERP system. That's a waste of human time. That's something that should be automated and let the people do something that's more creative. So that's what this bank was trying to do, was the same thing, is allow the people to handle the cases that are more sensitive or subjective and let the machine take care of the ones that were relatively easy. I touched on deploy, and the magic of the deployment really resides in the bot runner. The magic there is ultimately being able to put the code wherever you want to put the code. We have a cute little demo we do where we took an early version of our image classifier, and we put it into a Raspberry Pi, little robot car, and you lay a bunch of documents on the ground. And as it drives over the documents and follows the path you laid out, it says, this is an invoice, this is a purchase order, this is a passport, this is a driver's license. And it's recognizing the document so it can then kick off the right workflows to process those documents. Well, clearly, the Raspberry Pi is not the most compute power you're going to run into in this world, in spite of the fact that the Raspberry Pi 4 launch was hosted on a bunch of Raspberry Pis. I'm very impressed with the group for doing that. The demo itself ultimately takes a tremendous amount of compute power to create the classifier that we did. So by using something like the bot runners, I can do the training on a GPU box that was local to my data scientists, and let that run for the 3 days it takes to compute the model. And then I put the model down in the Raspberry Pi and let the Raspberry Pi execute. There was an earlier question about what's the compute load that RPA imparts on a company's infrastructure. And one of the things I love about RPA is you get to actually make choices. Where are you going to run things? The control room understands that this job needs a GPU, so it needs to go on a GPU-style box, as opposed to something that needs to run on a laptop to replicate some human behavior for what we were doing.
Is that something that you could then, I don't know, run something on a public cloud environment on demand? So you develop some certain tasks like that, it temporarily brings up an instance automatically in, say, I don't know, AWS, and runs it on an instance, shuts it down, and deploy it wherever it needs to run from.
So certainly all of that is possible. And I'm going to stop at possible because ultimately what's important is where is the data and who owns the data and who's running the system. So if we're responsible for it, that's exactly what's going to happen. We're going to have a cloud-based infrastructure and we'll spin up the resources we need to do the compute work. But if a customer is on-prem, whether they're running in Amazon or whether they're running in their own environment, they may have different choices about where they want to run things. So while the system can do things, what's appropriate for them is a decision that business is going to have to make. So we bring the tools, and it's up to the business to make sure they put it together in a way that makes sense. Makes sense for them anyways.
Okay. Can you just clarify one thing? So when you have native AI service and partner service, so that means what you had before, the ecosystem?
Yes.
But also your own, which uses TensorFlow?
So IQBot does not use TensorFlow. We've built our own set of tools. There is a number of third-party libraries that we've consumed inside of that. But when we started that development application, we were very much focused on making sure it was on-prem and making sure it was a self-contained piece of code to execute. That was probably about 4 years ago when we started the cognitive work. IQBot is really an example for us of how to build a cognitive skill end-to-end, and the learnings from building that and making it successful have really influenced how we've gone forward with the architecture and how we expose things now versus how we exposed things 4 years ago. So IQBot did not leverage as much of this as we could have. That's not to say we won't change that as we move forward. We're currently in the process of opening the engines up so third parties can put their own extraction engines in for specific use cases that we don't necessarily handle as well. So that's coming shortly. I'd love to say a date, but I can't yet. But that training, that learning that we took from the experience of building it is what's helped informed where we're going here. And so there's nothing like learning than just doing it, jumping in, making it happen, building the experience set, and then using that to generalize. The final step is learning, and no surprise at this point in my presentation that the learning also runs in a bot runner. And again, you'll put it in a place that's appropriate for updating your model. And that learning ultimately can be coupled with a UI, because if you want to do a job where you've got a human providing feedback at the end of the transactions, like on the mortgage ones, some go through automated, some go through a human, the UI is the place that they would do that. And in some applications, people will say, well, training is training. So we're going to put the learning and the training together. But the user flow for dealing with a single document and an exception on a document is usually very different than the user flow of how do I take 1,000 documents and kind of do some bulk training at the beginning. So that's why we've left them as separate steps so that they can deliver for the end user the right value at that step in the process for what they're doing. Architecturally, it's pretty straightforward in terms of what they're doing. But it was important for us to make those separate concepts so they could be treated appropriately. IQBot, I've talked about it a fair bit through here. IQBot really started out with a set of vision skills that grew to include language skills as we take documents apart and try to understand what's in them. Our goal with IQBot is ultimately not to have somebody sit down and say, how do I program this particular form, but build classes of forms. So that if I need to know I'm processing an invoice, I don't have to tell a human that there's dates at the top, there's addresses, there's going to be a table of items, there's going to be a footer down at the bottom. The human knows that, and they know what to go look for. And so different types of invoices all get handled the same way, and you really want the processing to happen at the feature level as opposed to the processing happening at look for this XY coordinate, try to find the bounding box, right? That's not very robust, nor is it very adaptive. But if I'm operating at features and the document system is taking those features out, it becomes a much stronger system. So we started with vision skills. We added the language skills to basically understand the components of the document and tease it apart. We're now expanding those out to support other use cases that are unstructured entirely as opposed to semi-structured. The conversation skills we support ultimately through partners, as well as the voice skills. Ending with AI Sense, Steve talked about this a good bit in his presentation. One of the things we want to be able to do, and Mihir talked about this, and I think someone asked the question about, you mean you can do everything for anybody? If you're going to automate anything, you have to be able to build APIs where APIs don't exist. And one of the places APIs don't exist are at the glass. So if I've got a Citrix screen or if I've just got a bitmap of an interface, I can't necessarily say, what's the DOM element that I want to go grab there? I've got to start at an image processing step and recognize what's a field, what's text, what's a checkbox. And then from that, infer meaning on it that I can then attach a bot to that I can go do work with. And so AI Sense is the tool we use that does that extraction of information, so you can operate all the way up at the glass if you need to.